Greetings to all learners. Professor Piyush here welcomes you all to this free Rhino 3D course. This course is based on the Rhino Level 1 and Level 2 training manuals. This course is designed to help you master the essentials and advanced techniques of Rhino 3D. Whether you are a beginner or looking to refine your skills, you'll gain hands-on experience and practical knowledge to bring your ideas to life. Let's dive in and start creating. But before starting anything, it's very important to understand what is Rhino. Rhinoceros, or also known as Rhino, is a versatile 3D modeling software, which is very widely used across various industries and creative fields. If I make it short to understand, I can say that Rhino is primarily a surface modeling tool, which offers an extensive range of functions to support diverse workflows. So whether you are crafting intricate designs or solving complex modeling challenges, Rhino can adapt to your needs with super ease. Some users, based on their modeling requirements, are able to explore only a fraction of capabilities of Rhino, while some get chance to dive deep into its advanced tools, which is a huge library to explore. It's so huge that even professionals using Rhino on daily basis get surprised time to time when they discover new and powerful features which they hadn't encountered before. So in this introduction video of the Rhino course, we will take only a broad look at the key elements, and slowly as you start using Rhino 3D and make yourself comfortable with these tools, you will start bringing your ideas to life. So let's uncover and see what Rhino has to offer and how it can transform your creative process. Let's start with understanding how objects are identified in Rhino. As I told you before, that Rhino is primarily a surface modeler. But what does it mean? It means it focuses on creating and editing digital surfaces. These surfaces are mathematically defined, infinitely thin, and infinitely flexible, which makes them ideal for precise and complex 3D modeling. In Rhino, surfaces are just one of the many object types you can work with. There are so many other objects as well, but surfaces are the foundation for creating everything in Rhino. It can be simple shapes or highly intricate designs. It doesn't matter whether you are building architecture, designing products, or crafting digital sculptures, everywhere surfaces play a critical role in bringing your ideas to life. So in this section of the introductory video of the Rhino course, we will explore the various object types Rhino supports and how they interact within your projects. First and most important object type is surfaces. So how do we identify a surface in Rhino? One of the ways by which surfaces are represented visually on screen is by showing the outline curves combined with interior curves, which are also known as isocurves. Or if you want to have some sense of substance with some light and shadow effect, the surfaces can be represented as shaded displays. Now, you must be wondering how these visuals changing. These visual representations can be changed by using various options of the display mode in the viewport. But just to make it clear, these are just visual representation. They do not alter the actual surface itself. Every point on a surface is calculated using complex mathematical formulas. For sure, it's happening in the background, but this precision ensures exactness rather than relying on approximations. This precision allows Rhino to handle intricate designs and maintain accuracy throughout the modeling process, making it an indispensable tool for various fields like architecture, product design, and more. Another important object type is polysurface. So in Rhino, you can create objects made up of two or more surfaces joined together. These are called polysurfaces. A polysurface is formed when the edge of one surface is very close to the edge of another within the tolerance specified in the file settings. We can control this tolerance settings also. I will tell you this in detail in later videos of the course. For now, you just watch. You don't need to practice for this video. This is just for your understanding before moving ahead in the course. So pay attention. Polysurfaces are versatile for when it comes to create complex models, but there are some limitations when it comes to editing them. But don't worry, to address this, Rhino provides tools to easily extract individual surfaces from a polysurface for adjustments and then rejoin them seamlessly. We will learn that also with many more exercises lined up for you in later videos. Now, because of this flexibility, you can manage and modify even the most intricate designs without compromising the integrity of your model. It is very important to understand how to work with polysurfaces. It is a key to master advanced 3D modeling in Rhino. Another object type is solids. As I told you before, surfaces in Rhino are infinitely thin and have no inherent thickness. So, how do we get solid object with thickness? Because real world objects require thickness or volume to represent their physical form. Rhino provides two methods to create objects that simulate thickness, which are known as solids in Rhino. First is closed surfaces. It means a single surface can be closed upon itself without any openings. Examples include spheres and ellipsoids, where the surface fully encloses a space. Second is joined surfaces. You can join multiple individual surfaces to enclose a space completely. A box, for instance, is formed by joining 6 surfaces. So, for any shape or form to qualify as a solid in Rhino, there must be no gaps, not even tiny ones, between the joined surfaces. From the properties of that particular shape or form, we can easily identify what type of object it is recognized by Rhino. It's essential to understand that Rhino solids are not filled. They are hollow volumes enclosed by infinitely thin surfaces. If you remove one side of a box, you'll see the back side of the remaining surfaces. Mastering solids allows you to represent objects with realistic volume and form, which is vital for visualization, prototyping, and fabrication. Another important and widely used object in Rhino is curves. Curves are a fundamental object type in Rhino and play a crucial role in surface modeling. In Rhino terminology, the term curve encompasses a variety of geometric shapes, including lines, polylines, which is a series of straight line segments joined end to end, arcs, ellipses, and circles. There are freeform curves as well, which are generally smooth and flowing shapes. Additionally, polycurves are formed by joining two or more curves end to end. If needed, polycurves can be separated into individual curves using the explode command. Curves are also essential as inputs for creating and editing surfaces, like trimming a surface or polysurface. They also have standalone utility. They are valuable for tasks such as generating 2D drawings from 3D models or serving as reference or construction geometry. Rhino also allows you to derive curves from surfaces. For instance, you can extract edge curves or surface isocurves to support advanced modeling operations. By mastering curves, you gain control over the foundational elements that drive Rhino's powerful modeling capabilities. Last important object which comes very handy during complex modeling or prototyping is polygon mesh. In Rhino, polygon meshes are another object type used to create and edit 3D models. Unlike surfaces, polygon meshes are made up of points which are also called vertices. These vertices are connected by straight lines to form polygons, usually with 3 or 4 sides. Some key points we should know about polygon meshes. The 3D data is based only on the vertices. The space between them is not considered. Dense meshes are more accurate, but still not as precise as surfaces. Meshes are commonly used for visualization, exporting for 3D printing, or rapid prototyping. Surfaces are highly accurate, while meshes offer a practical way to display models on screen or create files for specific manufacturing processes. Rhino provides tools to generate and refine these meshes from surface models for optimal results. We will cover all of them gradually as you start learning with me. So that was a brief overview for the basic understanding of Rhino or what is Rhino 3D. See you again with next lesson.